Very good morning to all the aspirants. Welcome to TSAT. TSAT prestigiously conducting Gurukula Udyoga Guide program. As a part of today's program, today we are going to discuss about how to prepare for JL and DL chemistry content. That is paper 1, paper 2 for DL and paper 3 for JL. Myself, I am Vasundhara Katamoni, a JL in chemistry. Along with us, Professor Anantha Lakshmi garu, senior most subject faculty, is here with you to discuss about today's topic. Now, Anantha Lakshmi garu is going to explain about inorganic chemistry, how to prepare for inorganic chemistry.
Thank you. Before going into the subject discussions, first of all I want to tell you about how will be the pattern of the questions in the subject. Not only the chemistry subject, for every subject this type of questions will come. Type 1 is multiple choice questions with only one correct option. So, very simple ones actually. Options 1, 2, 3, 4 will be there. Out of that, one option will be correct. And type 2 is statement based questions, like which one of the following is correct or which of the one of the following is not correct, like questions will be there. And type 3 also multiple statement based questions, but in that 2 or 3 statements may be correct. So, like if you see the in the screen the following, like A, B, C, D, A blah 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 blah, B, 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 like that, and out of the A, B, C, D few will be correct. So, choose the option in which of the following is correct. So, like A and B or B and C, A, C and D, like that options will be there. In that you have to choose which is correct. So, it is a multiple statement based type, and simple match the following will be there, and not only simple match the following, there is another type of the matching questions, like some pairs will be there. For example, oxide and property. So, some pairs will be there. In that, which pairs are correct, which of the above pairs are correctly matched, like that questions also will come. These are the different patterns what we come across in these exams, and most of the paper will contain first of all the only type 1 and type 2, type 3, type 4, type 5, few questions will be there in these patterns. But these are the questions which decide the ranking of the aspirant, because type 1 usually not so difficult, but 3, 4, 5 they will be of difficult model. And not only that, in every paper 70% will be of the average, and 20% like that above average, and 30% will be the difficult level. So, these difficult level questions actually decide the ranking. So, and particularly in chemistry, and we have 3 disciplines in this: inorganic, organic and physical. Out of the 100 questions, the ratio will be followed definitely 1:1:1. So, usually 33 to 34 questions of each branch will come. Suppose 33 inorganic, 33 physical, then 34 organic, like that. So 2 disciplines will be of 33 and 1 discipline will be of the 34. When you come to the inorganic chemistry, and the portion is divided into 13 parts in the DL exam and 12 parts in the JL exam. Only the difference between the DL and JL is only one chapter is extra in DL, that is a symmetry topic. Apart from that, all other topics are the same for both DL and JL. So, we are now discussing one after the other, how to prepare and what type of questions usually we will get. First topic is atomic structure and chemical bonding. In that, structure and bonding in homo and heteronuclear molecules, applications of Esper and all is the syllabus. So, in this we have to focus on Bohr's model, Planck's quantum theory, line spectrum of the hydrogen, real behavior of matter, Heisenberg's uncertainty principles, orbitals and quantum numbers regarding the atomic structure part. So, usually in this atomic structure part, definitely one question will come definitely. That is suppose for example like this: in an atom, the order of increasing energy of electrons with quantum numbers, some combinations are given, and in that which is correct, that we have to see. It is the like increasing order question, yeah? Increasing order question, less than, increasing order question. This type of descending, ascending is also one type of the patterns in the questions. So, this is one type. Here the hint for this question is, the lower the value of the n plus L, for an orbital, then the lower is the energy. So, in that way we have to go. If two orbitals have the same value of n plus L, then the orbital with lower value of n will have the lower energy. So, in that way we see how the energy will be. Then chemical bonding, this is actually the most important topic what I feel, because definitely usually three questions will come from the chemical bonding, because it is a vast subject, though to look the syllabus is only of the 5 lines, but here you have to have the whole knowledge of the inorganic chemistry, even groups, noble gases, every topic wherever we come across structure and bonding, those also can be asked under the heading of the chemical bonding. So, not just in chemical bonding, if you take any book, in that only few examples will be given under the sp, sp2, sp3 or vesper and all, but even in other chapters also these type of structure and bonding may be discussed for regarding some oxo acids or oxides and all, they also can be asked under this chemical bonding chapter. So, here usually we get some 3 questions definitely. So, in that usually one will be the match the following. If you see the whole papers, you will come across usually one match the following question also in this. For example, like this, list 1 and list 2, you have to choose the option in which the items of list 1 are correctly matched with the items of the list 2. So, these are the usual questions. I am not going into details of explaining this whole thing, because it takes so much time, but only to tell you what type of questions you will come across. Then chemistry of main group 1 to 7 and noble gases elements, but this nomenclature is now replaced, not 1 to 7 actually, 1, 2 and 13 to 17. Actually now the groups are named as like that in new periodic table. Then under that only one line is given in your syllabus, but in this vast syllabus is there actually. For every group you have to learn about the physical properties, chemical properties, uses, right. And for example, in the first group, even anomalous behavior of lithium, diagonal relationship of lithium with magnesium, and second group, anomalous behavior of the beryllium, diagonal relationship between the beryllium and aluminum. And not only these things, in every group some important compounds will be there, like sodium hydroxide, sodium carbonate, sodium bicarbonate, calcium hydroxide, cement, silicones, silicates, oxo acids, oxides of 5th group, 6th group, and in the noble gases the compounds of the xenon. So, all these come under this particular heading, chemistry of main group elements. So, here also you can expect more questions from this topic. So, like this, the reactions in the chemical properties, many reactions will be there. So, those reactions are also important when you come for the exam. Which of the following metals react with dilute sulfuric acid and give hydrogen gas? Suppose this is the question. 1 copper, 2 iron, 3 zinc. Out of the 3, which are giving acid, hydrogen gas with this sulfuric acid? So, the correct option is 2, 3, that means option 2. 2 is iron, 3 is zinc. Iron and zinc will give the hydrogen gas, but copper will not give, because copper is below the hydrogen in the reactivity series. And even like consider the following pairs, oxide and property are given, which of the above pairs are correctly matched? This is one sort of the matching type question. It is not exactly what you feel like match the following, it is another way of the match the following, which pairs are correct. So, here you must know about the oxides and their properties, what are the neutral oxides, what are the acidic oxides, what are the amphoteric oxides, what are the basic oxides, then only you can match very clearly this. Here for example, carbon monoxide is neutral, that is correct only, and PbO is amphoteric, and next one thallium oxide is the basic. So, A, C, D only, that is the correct option. B is not correct, it is not acidic. N2O is also again neutral. Then chemistry of transition elements and inner transition elements. In this much syllabus is there to look into, but usually we will get one question each from transition elements and inner transition elements, and that too mainly on the electronic configuration, their oxidation states, color. Regarding that only usually we come across the question in the chemistry of the transition elements and inner transition elements. For example, if you see here, which pair of ions exhibit color and possess same number of electrons? We have to observe very carefully. Here suppose first pair, if you see, they are colorless, they are not having any electrons also, and second pair, third pair, fourth pair, like that if you examine, see the table I have given here, one reference table. Option 3 is correct, europium 3 plus and samarium 2 plus. Europium 3 plus is F6, samarium 2 plus also F6, both are colored. In other options, either both they are no color and no electrons, or color is there, electrons are not matching, or if electrons are matching, color is not there. Like that the combinations are given here. So you have to closely observe, and you must be very much familiar with the electronic configurations of these transition elements and inner transition elements, because there are some anomalies in these electronic configurations. That is why usually the questions will come in this pattern in these chapters. Then general principles of metallurgy. Here the syllabus is given, complete syllabus is given only for this topic in the syllabus, right? And usually we get some 4 questions out of the whole inorganic chemistry, chemical bonding, general principles of metallurgy, symmetry. These are the 3 topics where you get more questions. Out of 33, 12 questions you will get only from these 3 topics if you closely observe the old papers: chemical bonding, general principles of metallurgy and symmetry. So here you must be thorough with the minerals, ores of the elements. One question definitely come from that part only, and then later only the other things. And nowadays Ellingham diagram is also gaining importance in giving questions, because it is introduced newly, this concept Ellingham diagrams, in intermediate books also. And for this particular topic, intermediate second year book is very best book to prepare for the general principles of metallurgy, because it is not dealt in any degree syllabus or PG syllabus. Only in intermediate this particular topic is there, and that too Telugu Academy book is the best book for the general principles of metallurgy. So like the questions, match the following: list 1, list 2, mineral and composition. Mineral and composition, or sometime type of mineral, that means whether it is oxide or carbonate, like that also will be given. So these type of questions will come in the metallurgy. Definitely one match the following will come from the metallurgy. This is one sort of that question. Then concept of symmetry in molecules. So this is actually a broad topic, and here also will come across definitely three questions definitely you will get, and every aspect is important here. For example, you see the number of dihedral planes present in CH4 is CH4, it belongs to tetrahedral point group. Once you know the point group, it is very easy to tell about the dihedral planes, because what are the elements present in the tetrahedral point group we will know. So in that 6 sigma d planes is one option. So 6, that means option 2 is correct, the number of dihedral. Here point groups also will be asked. The point group of for example, the point group of staggered ethane is, or the point group of the staggered bisbenzene chromium is, or sometimes 2 clubbed. The point group of the staggered ethane and staggered bisbenzene chromium are respectively. Like that questions will come here. And even the number of symmetry elements present in so and so molecule, then you must know that the point group to which it belongs. Suppose ammonia, C3V is the point group. If C3V is the point group, then H is equal to 2N. So 2 into 3 is equal to 6. 6 symmetry elements are present in the C3V point group. So ammonia also having 6 symmetry elements. So like that some concept based questions will come from the symmetry of the molecules. Then coordination chemistry, it is also very important topic. Here you definitely will get some 4 questions, usually some 4 questions will come for this coordination of chemistry, and that too crystal field stabilization energy and even magnetic properties, These are all very important, and even term symbols. One particular question I am showing here, the magnitude of the crystal field splitting and the mean pairing energy for CrH2O6 plus are 13,900 and 23,500 inverse centimeters respectively. The CFSE values for high spin and low spin states of CrH2O6 plus are respectively. This is the question. So, this is a problem based question. So, chromium, what is the oxidation state of chromium in that complex? It is 2 plus. So, chromium 2 plus means the configuration is 3D4. If it is high spin, then T2G3 Eg1 is the configuration. That means in the T2G 3 electrons are there, in Eg level 1 electron are there. So, in the electron in the T2G level will have minus 0.4 delta O energy, and in the Eg level will have plus 0.6 delta O energy. So, based on that, if you calculate, the CFSE is of the minus 0.6 delta O. Delta O value is given. So, minus 0.6 into 13,900 comes out to be minus 8,340. See, if you see, there is only one option having minus 8,340. So, if you do not calculate further also, you will put the option, but sometimes examiners will be having giving the options very tricky. Some two options may be having minus 8,340, then you have to calculate for the second one also. If you calculate for the second one, here it is a T2G4 low spin, that means one electron is paired up. So, 1 plus 1 pairing energy you have to add, then the calculation comes out to be 1260 inverse centimeters. So, the option 3 is correct for this question. So, like this problem based questions will come from the coordination chemistry. Coming to the stability of metal complexes, here from the Pearson's theory of hard and soft acids and bases, there usually questions will come. Of course, factors affecting also will come, but this is important. HSAB principle is important. So, based on that only, which type of the compounds can be formed easily and which cannot be formed easily, which are stable, which are not stable, all that we can decide. So, one such type of question is which of the following statements are true. See, here it is the multiple statement based question. 3 statements are given. In that, how many statements are correct? Here the B and C statements are correct. First statement, actually it is the fluoride complex is more stable than the iodide complex. So, reverse is given the options there. So, B, C are correct. So, option 3 is correct for this. Then reaction mechanisms of metal complexes. It is again very vast subject and completely MSc based topic. 2 questions usually come from the reaction mechanisms of metal complexes. Because of the time factor, I am not going to discuss any questions here. Of course, I am shifting to next topic, metal carbonyls, nitrosyls and metallocys. Here also structure and bonding is very important regarding the carbonyls and nitrosyls. For example, which of the following complexes contain bent nitrosyl group? Because here they may be having the linear or bent nitrosyl groups. Some will be having only linear, some will be having only bent, some will be having linear and bent. The question is asked contain bent. So, if it is having linear and bent also comes under this option, because here it is not asked that contain bent nitrosyl only. If it is given bent nitrosyl only, then you have to look about the option which is having only bent nitrosyls, but contain bent nitrosyl. That means if it is having any linear nitrosyl also comes under this option, right. So, option 1, that is A, C, D only. These 3 are containing the bent nitrosyl groups. That C option in here, there the nitrosyl is not bent, it is linear. Bioinorganic chemistry, metal complexes as oxygen carriers, hemoglobin and myoglobin, oxygen transport, non-heme proteins and all. Here about the hemoglobin, myoglobin, hemerythrin, hemocyanin, how their deoxy forms, how their oxy forms are very much important. So, and even factors affecting the oxygenation of the hemoglobin also important, though it is not mentioned here, but usually the questions come because hemoglobin and myoglobin means oxygen transport. So, what are the factors affecting this oxygen transport? From that also questions will come, right. So, for example, the oxygen carrier which holds oxygen as a hydroperoxide is, see, hemoglobin it carries as oxygen, myoglobin also it carries as oxygen, hemerythrin it carries as hydroperoxide, again hemocyanin is a, it carries as a bridged oxygen. So, hemerythrin is the correct option for this. So, like this you have to rule out the options. Then coming to the analytical chemistry, chromatography, general principles involved in separation by paper, thin layer, column chromatography, GC and HPLC. Usually 1 or 2 questions will come from this topic, and mostly the problem based questions we have to concentrate on it. For example, this question, in the analysis of an organic compound by paper chromatography, the solvent front was 18 centimeter, while the front due to the compounds A, B, C, D were the values are given, and RF value of one of the compounds is 0.794, 0.1794. So, what is that compound? So, RF value is given 0.794. So, RF value is what, actually RF is equal to the distance travelled by the compound by the solvent front, right. So, distance travelled by the compound by solvent front is equal to RF. So, RF into solvent front, RF into solvent front is nothing but the distance travelled by the compound. So, like that if you calculate, RF is 0.794 into solvent front is 18, then 14.3 will be the answer. So, 14.3 corresponds to which compound? The B, the compound B travelled 14.3 centimeters. So, compound B means option 4. So, like this the questions will come, even about the detectors, the principles and theories, all are important. Here we cannot say this is not important, this is important, because every nook and corner the paper setter can pick up, but particularly statement based questions we cannot expect what type of statements will be lifted. So, everywhere sometimes we will overlook about the uses, but from the uses they may pick up the statement, and from the simple physical property they may pick up the statement. So, like that. And particularly in organic chemistry, the reference books what you can follow are intermediate books first year and second year, and inorganic chemistry by Hui and inorganic chemistry by Puri, Sharma and Kalia. At least these books if you follow thoroughly, then you can crack the questions regarding inorganic chemistry. Now, over to Vasundhara madam, she will discuss about the organic chemistry and physical chemistry.
Thank you very much, ma'am. Ma'am nicely explains about how to prepare for inorganic chemistry. Now, we are coming into the another important areas of chemistry, physical and organic chemistry. Now, let us move to physical chemistry. So, physical chemistry. So, first we have to go through the syllabus first. In physical chemistry, we have 9 chapters: solutions and colligative properties, acids and bases, thermodynamics, electrochemistry, quantum chemistry, chemical kinetics, photochemistry and solid state chemistry. Now, let us discuss about each and every topic in brief. First, when coming to solutions and colligative properties, here the syllabus given about types of solutions, expressing the different concentration of solutions and colligative properties and phase rule. So, in this very important areas, most probable questioning areas are expressing the concentration of sample by different methods, like mass by mass, mass by volume, by mass by volume, volume by volume, and next molality, normality. So, from these topics we may expect some numerical based questions and some statements questions too. Next, when coming to colligative properties, we have different colligative properties. So, this is also one of the important area. When you see the previous papers, The questions are came from these topics. So, these are very important areas for the examination. Now, let us see some sample question from this chapter. The vapor pressure of acetone is given at 20 degrees centigrade when 1 grams of non-volatile substance was dissolved in 100 grams of acetone at 20 degrees centigrade. See, this question, when you analyze the data given in the question, it is related to relative lowering of vapor pressure. If you substitute the values directly into the formula, you will get the answer. This is directly formula based question. Next, when coming to another question, the elevation in the boiling point of dilute aqueous solution is given and they ask you to find out delta TF, freezing point temperature. So, the relationship between delta TB and delta TF is delta TB by delta TF is equals to KB by KF. By using this concept, you have to calculate the delta TF value. Here, the values of KB and KF for water is given. So, these kind of questions we may expect from this chapter. So, most important topics from this chapter are concentrations as well as colligative properties, and from this is very important topic in the physical chemistry. From this we may get at least 4 questions. Next, when coming to acids and bases, this is very easiest and important topic. Acids and bases, first we have to go through the different theories of acids and bases, and generally from this topic we may expect pH calculations question. pH concept is very important in this. pH calculation of buffer solutions also very important. So, let us move to the question. See that question, calculate the pH of a buffer made up from 0.2 mole per liter acid and 0.4 mole per liter of that conjugate base. Here conjugate base is given, concentration of conjugate base is given and concentration of weak acid is given. Directly calculate the pH of the buffer solution by Henderson equation. pH is equals to pKa plus log of concentration of conjugate base by acid. So, these kind of questions mostly we expect from the pH concept from this topic. So, this is also one of the important topic in physical chemistry. From this we can expect 2 to 3 questions. Next one, this is another important question. The dissociation constants of acids are given. So, they are asked to calculate basic strengths. So, there here given dissociation constants. So, this is relative strength of basics is the reverse order of the acidic strengths. So, we can go through that topic, then only you have to answer that question. Next topic, thermodynamics, a very important topic in the physical chemistry. Each and every aspect is important in this topic, thermodynamics. So, we have to start your preparation from intermediate level for that topic. We have to go through the laws, 0th law, first law, second law, third law of thermodynamics, entropy, enthalpy, Gibbs free energy, Helmholtz free energy, Maxwell relations. We can expect a direct question from the Maxwell relations also. So, Gibbs free energy, relative signs of delta H, delta G, delta S also very important for this examination from this topic. Now, let us move to one question about this thermodynamic. This is a very small question, very easiest question, directly a formula related question of delta S, calculation of delta S. So, here heat is given and temperature is given. Just by substituting the formula delta S is equal to Q by T, you will get an answer. So, let's move to another question. Here signs, this is based on the sign conventions of delta H and delta S, delta G. So, here the equation is given, delta H and delta S values are given. See, delta H and delta S both are positive here. So, when will delta G is negative for this situation? So, whether a reaction is spontaneous means delta G is negative. So, if our delta H and delta S both are positive here, when temperature is high, temperature is favorable for the spontaneity of that reaction. So, in that option, high temperature is above 2000 Kelvin is very essential to perform the spontaneous reaction for this. Next, let us move to another important topic, electrochemistry. This is also one of the main topic in the physical chemistry. In this is also we have to start your preparation from intermediate level to up to PG level. So, for this concept we have to go through the different cell notations and different kinds of cells, EMF measurements, Kohlrasch law, very important topic in the electrochemistry, and Debye-Huckel theory is law, electrophoretic effect, Zerum theory of ion association, dissociation. Mostly from this topic, questions from graphs can be, we may expected. So, let us move to one question about this electrochemistry. See this is about a salt bridge question. So, first of all, what is salt bridge? Salt bridge is a device which connects to two electrodes. Salt bridge may be glass or filter paper. So, generally in the laboratory glass is used for better performing. Next, so for salt bridge weak electrolytes are used. So, what is the main use of the salt bridge? To maintain the neutrality between the two electrodes. So, for maintaining the neutrality between the two electrodes, the transport numbers of anion and cation must be equal or nearly equal for the salt bridge. See that question, table is given for different electrolytes. From that table, only AB and IJ both are having equal or nearly equal values of transport numbers. That type of salts only very convenient for the usage of salt bridge. Next, when coming to the another question, this is a cell notation is given. They are asked to calculate delta G. This is directly a formula based question. Delta G is equal to delta G naught plus RT log concentration of zinc plus 2 by concentration of copper plus 2. You have to substitute the data given in that question and you have to substitute that in the question, you will get an answer. So, mostly numerical problems we may expect from this chapter as well as statement questions also, and some match the following questions like different types of electrodes, hydrogen electrode, quin hydron electrode, different types of electrodes are there for laboratory purpose. So, cell notations for different electrodes are also given like a match the following type of question. Next, when coming to quantum chemistry. So, before going to explain about concept of quantum chemistry, let us discuss about basics of atomic structure. So, basics of atomic structure is very important before reading of quantum chemistry. So, we have to go through the different models of an atom and radius of atom, radius of Bohr's orbit, and they have some formulas are there to calculate the energy of an electron, radius of an electron. So, first we have to go through the atomic structure, after that you have enter into the quantum chemistry. So, in the quantum chemistry we may expect questions from operators concept, operators algebra. So, various types of operators are there. So, let us move to one question regarding this topic. The eigenvalue of d square by dx square sin x plus cos x. Differentiation operator is given, eigenvalue. Differentiation of that sin x plus cos x gives the eigenvalue of that function. So, we have mathematical knowledge for to solve this type of questions. Mainly from operators concept we may expect questions from this area. So, from this concept we may expect 2 to 3 questions. Next, when move to another question, here two operators are given A and B. They are indicated that they are not commute with each other. Commute with each other means AB not equals to BA. So, this is A plus B whole square, that is like A plus B whole square like formula. So, by doing the operation you will get the answer a square plus b square plus ab plus ba, not 2ab. Why? Because these are not commute with each other. ab not equals to ba, then the answer is first option. Now let us move to the another important area of physical chemistry, chemical kinetics. In this we have to go through the different order, first order type, second order, third, like the 0th order. So we have to first we have to go through the formulas related to that and different theories related to the chemical kinetics. Now let us move to one question. See this, here K1 and K2 rate constants are given and they given identical pre-exponential factor. So the relationship between rate constant and pre-exponential factor is K is equals to A into e power minus Ea by RT. Okay. By using that equation you can solve this kind of question. Next, when move to another question, this is opposing reactions, forward reaction and backward reactions, rates are given. So this is a graphical type question. They ask you to tell about the intercept of the of that graph. See that this is a straight line passing through origin type of graph. So the intercept for this graph is 0. Next, then move to another important topic, photochemistry. So in the photochemistry, first we have to go through the different photo processes like fluorescence, phosphorescence, IC, ISC, vibrational cascade. So these are very important. Understanding of these concepts are very important. We have to go through the Jablonski diagram. So we have to know the difference between intersystem crossing, internal conversion, vibrational cascade and fluorescence and phosphorescence. So in this again another important topic, most probable area for questioning is quenching, photosensitization concept, quenching concept and flash photolysis. Very important concept. As we move to the previous papers, mostly the questions from these areas only. So these are the main areas. Now let us move to the question which is related to this topic. See that question. The fact that fluorescent wavelength lambda is often much longer than the irradiation wavelength. This is according to Frank-Condon principle. What is Frank-Condon principle? Electronic transitions are more faster. So according to this principle, fluorescence is more faster than the irradiation wavelength. This is like a statement type question. From this you can pick the answer. Next question is match the following type question. See this question. So let us go to the first option, A star plus A is equal to 2A. So this process is what? So we have to know about quenching. Quenching in the sense lower the intensity of the fluorescence of a sample molecule. Self quenching in the sense self, the atom only quench the process of fluorescence of that excited molecule. See this here, A star excited molecule, that molecule fluorescence is quenched by the another molecule of same sample at a ground state energy level. So this is belongs to the self quenching concept. Next, fluorescence quantum yield. This is a direct formula, Kf by KIC plus KIIC plus Kf. Next, when coming to the natural radiative lifetime. Natural radiative lifetime is the reciprocal of the rate constant of the fluorescence process. Directly T is equals to 1 by Kf. Next, when coming to the fourth option, A star gives A plus heat. This is related to the internal conversion. What is internal conversion? This is a non-radiative process when electron coming from higher level to lower level with a retention of spin. This is called internal conversion. So for exercising this type of questions, we have a knowledge on all the topics related to that concept. So we have to go through the all the topics of each and every concept which is given in the syllabus. So, from the photochemistry we may expect 3 to 4 questions from the photochemistry also. So, next when coming to the another chapter, solid state chemistry, this is very easiest chapter. We have to go through the intermediate textbook about to learn about the solid state chemistry. So, in the solid state chemistry generally we have to discuss about different metal defects, imperfections in the solids, calculation of number of voids, octahedral voids, tetrahedral voids, nearest neighbor distance, packing efficiency, packing fraction, types of primitive cells. So, what is the contribution of each atom in the to the corners, to the face, to the body diagonal. So, that is very important. We have to go through the basics. After that you will enter into the PG level topic. So, let us go through one question. This is a question related to the fraction of, calculate the fraction of octahedral voids from the formula. So, first you have to analyze the data given in the question. So, next to calculate a number of octahedral voids and tetrahedral voids, then only you have to answer the question. Next, one more important topic in the solid state chemistry is magnetic properties of solids and superconductors, conductors, insulators, conductors, superconductors. So, superconductivity is this concept also very important for your examination, and magnetic properties, different theories of magnetism, Levy's theory and Wies theory of magnetism, problems related to that topics also very important, and different types of magnetic materials are available for us. So, we have to go through that topic also. Now, let us see a question related to that topic. See, which of the following is generally referred as 1, 2, 3 superconductor? This is very important question. 1, 2, 3 superconductor is yttrium, barium, copper oxide. This is 1, 2, 3 superconductor example. So, from the physical chemistry topic, each and every topic is important. There are 9 topics in the physical chemistry. Most important topics are thermodynamics and electrochemistry, photochemistry, chemical kinetics. These are all the very important topics for the examination. We may get more number of questions from that topic, and every aspect of syllabus given in that notification is very important. You have to revise in a planned way. Already preparation is over, hardly 1 month time is there. So, you have to revise a very planned way. So, this is about a preparation of physical chemistry given in the notification. Next, when coming to the one more important area, organic chemistry. So, let us move to the syllabus of organic chemistry. There is a vast syllabus in the organic chemistry. Planned preparation is must for that preparation of organic chemistry. So, first we have to start your preparation from IUPAC nomenclature and isomerism. So, let us move to IUPAC nomenclature. So, we have to go through the different rules of nomenclature, lowest sum rule, first point of difference rule, lowest number rule, and different rules are there in the IUPAC nomenclature system. We have to go through the IUPAC nomenclature system of simple molecule as well as complicated molecules like spiro compounds, bicyclo compounds also. First, we have to go through the naming of IUPAC nomenclature from the intermediate textbook. So, after understanding that concept only, you have entered into the different, you have to practice the different questions from that. Okay. See this is IUPAC name, we have to identify the name of that molecule. See this, from which side we have to numbering first, from left side or right side. So, we have to go through the rules. Always riding functional group must be having lowest number. So, if I give numbering from right sides, that that OH group consists of 4th number, from left side that is 3rd number. So, we have to go through the numbering from the 3rd left side of the molecule. So, the name of that organic molecule is 2-mercapto, SH. SH is a substituent here, prefix. So, for SH, the prefix for the SH thiol is mercapto. mercapto, 2 mercapto 5 hexane 3 ol. This is the IUPAC name of this compound. So like that you have to practice different questions. So just reading of rules is not enough for the cracking of this type of questions. We have to practice more number of examples from the books, from any other sources, then only you have to answer this kind of questions. Not only these simple molecules, you have to go through the bicyclic compounds, bridged compounds and spiral compounds. Next, when coming to the another vast area, hydrocarbons. So we have to go through the synthesis and properties of all the compounds given in the notification, like alkanes, alkenes, alkynes, alkadienes also. They are not mentioned in the syllabus, but alkadienes also very important. Cycloalkanes, aromatic hydrocarbons, carboxylic acids. For this synthesis and how to synthesis, some named reactions are there for the synthesis of different kinds of different hydrocarbons. That named synthesis, important reactions and different properties, chemical properties, we have to go through this topic. When coming to another very important topic of organic chemistry, this is like a very important heart of organic chemistry, stereochemistry. After understanding stereochemistry, you will be able to understand any topic which is related to stereochemistry in the organic chemistry. Otherwise, you can't understand. So, first you go through the stereochemistry topic. Stereochemistry. From this stereochemistry, we have to go through the different projections, wedge projection, Newman's projection, different molecular representations and their interconversions also very important. Convert from one projection to another projection is also we have to practice. For organic chemistry, practice is required like maths. So, we have to practice more number of examples. Next, stereochemistry and RS nomenclature. RS nomenclature for different chiral axis molecules, chiral planar molecules, chiral helix compounds. We have to practice the RS nomenclature for that, and EZ nomenclature also. EZ is not cis trans, for not for every time not cis is Z and for every time not trans is E. So, we have to practice more number of questions. This is like a mathematics. So, you have to practice more number of examples, then only you have to understand this topic. Let us go through the one question. Group the following compounds into chiral and achiral. So, what is the criteria for chirality? Chiral molecules are free from all the symmetry elements. See here, and first and second molecule, first and third molecule has plane of symmetry. So, this is not belongs to chiral molecule, and second and fourth molecule not having any kind of symmetry. So, these are belongs to chiral molecules. So, 1 and 3 are achiral, 2 and 4 are chiral molecules. So, this is just like this just related to the concept of symmetry. Symmetry, chiral molecules are free from all the symmetry elements like plane of symmetry and inversion. Next, when coming to another important area of organic chemistry, conformational isomerism. This is also very important. After stereochemistry, you have to go through this conformational isomerism topic. So, in this topic, we have to discuss about Klein-Prelog terminology and different stable conformations of different compound. A particular compounds are given for the study of conformations. We have to go through all the examples of that particular compounds, and Klein-Prelog terminology is very important. Next, when coming to the question, see, first we have a knowledge about different conformations, stable conformations, then only you have to solve this kind of question. See this is difluoro compound. Difluoro compound generally anti-periplanar is stable for other compounds, but this is due to less hyperconjugation in this, that anti-periplanar conformation is not stable conformation for that difluoro compound. This is exception in the conformations of difluoro compounds. This is very important conformation. Next, when coming to second one, dihydroxy compounds. For dihydroxy compounds, Gauche conformation is stable. Why? Because it can form hydrogen bonding. So, hydrogen bonding is a stabilizing factor. So, the Gauche conformation is a very stable conformation for that dihydroxy compound. Next, when coming to carbonyl compound. So, carbonyl and that bromine both are, one is axial, one is equatorial. So, axial, bromine is in axial position, is a most stable conformation for that type of compounds. So, the answers are 2 and 3. So, not 1. 1 for less hyperconjugation, no, there is no hyperconjugation in that conformation. So, that is a stabilizing factor. So, there is no stability for that type of conformation of difluoro compound. Next, when coming to nature of bonding and aromaticity, a very important topic. This is also like stereochemistry. So, will you, after going through these topics only, we have to understand that you have to go through the other topics. Nature of bonding and aromaticity. In this, we have to go through about inductive effect, hyperconjugation, resonance, and Huckel's rule, concept of aromaticity and anti-aromaticity. Homo-aromatic molecules also. Actually, that name is not given in the syllabus. We have to go through, we have to practice. Practice is very important for this topic also. This is very important topic. From this, when you see the previous paper, 2 to 3 questions are we may expected from this topic. See, this is a definite question from aromaticity. Definitely one question came from the aromatic nature of the compounds. See this, 1, 2, 3, 4. Out of this, 1 is actually, if you see this, that is like a planar molecule, but due to transannular effect, that is not a planar molecule. So, planarity is a must and should for aromaticity. So, that is not belongs to aromatic compounds. Next, when coming to the fourth one, that is also, they contain 10 electrons in it. So, that is also not coming to the aromatic compounds. So, here we have to use elimination technique. The options which are consisting of 1 and 4, we have to eliminate first. So, then the next one is 2 and 3, both are aromatic. So, that essential for the aromaticity, continuous conjugation and planarity, and 4n+2 pi rule. Next, when coming to reactive intermediates, intermediates, we have to go through the all the reactive intermediates, carbenes, nitrines. So, from the generation, how they generate, how the properties we have to discuss, and molecular rearrangement also. Each and every molecular rearrangement mechanism you have to practice. See this question, this is about how to generate different kinds of intermediates. So, this is like a multiple choice question. This type of questions we may expect from this. From the molecular rearrangements, you have to go through all the molecular rearrangement. From this, you can get this kind of question or mechanism kind of question we have to given. Next, organic reaction mechanism. This is also one of the most important mechanism, important topic in the organic chemistry. So, different kinds of mechanisms are there, SN1, SN2, E1, E2, E1CB. So, we have to go through all this. So, this is the kind of question. So, this is like a matching type. What is electrophilic addition from that options we have to get. So, free radical means in the presence of light, you have to identify very easily. Next, oxidation and reductions. In this, we have to learn about only chromium 6 oxidant and some particular oxidants are given. So, we have to follow, we have to practice the oxidate, what is the mechanism for that, and for reductions also you have to follow the particular one. See this, this is lead acetate, lead tetraacetate. This is gives a cleavage of 1, 2 diols. So, option is, second option is the correct answer. Next, dibal H. Dibal H selectively reduces that esters. So, not double bonds. So, it only reduces the esters. You have to know the property of that particular reduction compound. Heterocyclic compounds. In this, nomenclature is there and different compounds are there. Synthesis important, properties also important. See, this is one of the statement kind question. So, we have to pick a incorrect statement from this. So, Next, alkalides and terpenoids. Some particular concepts are given, particular compounds are given, we have to practice that mechanisms. These are some uses of as drugs. Organic photochemistry, already we discussed about photochemistry in the physical chemistry. So, there is an extension, different kinds of reactions are there in the organic chemistry, you have to go through that one also. This is like Norrish type 2. Norrish type 2 in the sense, it consists of gamma sp3 hydrogen. There is no, in first option there is no gamma sp3 hydrogen. So, the first option is the correct one. Pericyclic reactions, different methods, FMO method, PMO method, orbital correlation method, we have to practice. These are all very important topics, don't skip any topic from these topics. Spectroscopy, very important area of organic chemistry is a spectroscopy. So, each and every spectroscopy is important. So, from this we can get all the different spectra values are given, from this you have to identify the structure of a compound. Next, important and easy concept, green chemistry. So, from this we can expect very simple questions like what is green reaction and what are the statements given about principles. So, this is about preparation of organic and physical chemistry. For every topic preparation you have to make a short notes for the examination. So, that is useful for your examination. I hope this session is very useful to all the aspirants. So, thank you very much and all the best for your success.
I want to add one sentence.
Yes.
Okay. Yeah. Regarding organic chemistry, I want to add one point here. Here in organic chemistry, any question is not confined to a particular topic, because they are all linked topics, starting from hydrocarbons to carboxylic acids or esters. Some in some it may be the preparation, in some it may be the property. So, all linked questions will become A to B, B to C, C to D, D to E, and what is D or what is E, and the reagent, what is the reagent. Such type of questions are very usual in organic chemistry. So, you should have a complete knowledge of all the reactions, and put together you have to read, not just confined to one particular functional group. That is essential for the preparation of the organic reactions. All the best for all that.